objects. Okay, today we'll go on to do a little bit more challenging example and more challenging concept. I want to start with something that we have known already, but just as a reminder, because it's something quite important to note. So we talk about mutators versus accessors. Accessor means it's going to return something that should be useful. Okay, for example, get BMI. And mutator is something that is going to do an update quietly. In that case, it can be a set weight, set height. So let's see what the constraints are. First of all, if you're trying to call the mutator method, in this case, you cannot treat it as a value. So what do I mean? So let's say this. If you remember what you did for your lab number 2, let's say you got a set weight method over there. You say gym.setWeight 78.5. In this case, you're trying to print it out. So this is considered as an error. Because remember, the set weight returns void. So it doesn't return anything for you to be printed out. So this is not good. So it's not going to compile. Okay, how about this? Similar, right? In here, you can see you put the call to the mutator method on the right-hand side. In which case, you're expecting some double value from here. But set weight is returning void. It doesn't return a double. And of course, this line will not compile either. Okay, is it clear? Okay, for mutator method, you cannot expect any value to be returned, void. Okay, this is the right way to do it. You should really just put the mutator method alone, just over there. Okay, that one's okay. On the other hand, for the accessor method, it is supposed to return something for you to use. So you better use it. If somehow you just call the accessor method, let's say get BMI or get interpretation of BMI, but you're getting the string description or get a string or the double value, but you never use it, then why would you call the accessor method in the first place? So it's useless. For example, let's say here, you simply call gym.getBMI over here. The method itself is going to return some double value, but this double value is never used in anywhere. You didn't try to print it. You didn't try to really assign that to some variable. So this, although it will compile, but it's also considered not good, not very useful. Okay, why would you do that? Why would you calculate it? Okay, so this will be the right way to use it. You just print it, you can print it out, or you can assign that to some variable. Okay, so basically what this slide is trying to say, whenever you're trying to use a mutator, you cannot use the mutator itself as a value, like over here, right? The two cases where we see there should be a compile time error. On the other hand, whenever you're trying to call the accessor method, you better use it. Otherwise, why would you call that? Okay. Okay, this slide here, I'll just mention that briefly what this is about. So this is just some principle. Whenever you have some method parameters, how do you decide what kind of parameters you want to pass to your method? Okay. So what about for constructor? I would say usually the number of parameters you want to pass to the constructor depends on how many attributes you really want to initialize. Let's say in the person class, you got weight, you got height. In this case, you better pass maybe 2 values in the constructor to initialize maybe the weight and the height. Let's say you also have name. If you do not try to initialize the name in the constructor, you will have just default value, which is null, because string is a reference type, you know, stuff like that. So that's kind of the design issue you have to gain over experience. Now in this case, we have, so this is the constructor that we try to initialize first name and last name for the person, for example. Well, what to really put is really up to you. What about mutator method? Remember what the mutator is supposed to do. They're going to change something. And typically, the thing they want to change are the attribute values. So depending on how many attribute value you want to change, that can decide how many parameters you want to have. For example, set weight. You want to set the weight to be some new value. In this case, because you only want to set the weight, so only one parameter will be necessary. Or if you want to move up by some units, in this case, you only want to change the y value, the y coordinates, so only one parameter. Okay, similarly for accessor. For accessor here, this is really about how much information you really need in order to do computation. In this case, for example, let's say for this method here, we have, so we simply say, given the context object point, we want to know what's the distance from the context objects to the origin. Okay, and then the second one, so this one here you can see we take no parameter, which means All right. So the first one there, we simply take no input there. And then the second one, we simply take other points, which means you want to calculate what's the distance from the context objects to the other points. Okay? So that's kind of the principle. I would say just principle. So you can try to see if you understand it, just apply. Okay, I want to review about data types, and then we can get to something that's more interesting. Okay, today we'll do some little bit more challenging example. So in lab number 1, you talk about the string and double, right? That's kind of simple types. But in Java, you can take more complicated type for your attributes. That's something I would like to show you today. You can do more interesting application with that. Okay, let's review what data types are. First of all, when you talk about runtime values, for example, you got 1, 2, 3, double quotes, S, double quote, York University, right? These are strings, and some other things are integer or different types. Whenever you can group some relevant values together, you call them a type. For example, you have primitive types in Java, which you learned already. Just go through very quickly. You got integer, you got floating points, depending on the capacity you need, and also got character, okay, and Boolean. So these are the primitive types. And everything else is considered as reference type. You can see that the very familiar string type is not here. So string is not considered as a primitive. It is not, okay? So now for the reference type, so somehow they have some complex attributes and methods which you can call upon their objects, okay? For example, you have string, and you have person, you have points, and maybe you can have scanner, many things, many other things. Basically, you have way more reference types than primitive types in Java, okay? Basically, every class you can declare in Java, they are a reference type. Okay? Questions so far? It's just concept, yeah. Just floating point, which means you got a fractional bits over there, yeah. Okay, so now this one, let's say this. Just talk about default value very quickly. I mentioned default value about several lectures ago. Let's see this. For default value here, for primitive type, so default value, which means if I simply say integer I, so this is only decoration. I'm not giving any initialized value to I. In this case, it will just be 0. Okay, that's for numbers. Or you can have 0.0 for double. You can have false for Boolean, and that's it. Okay. Now, what about reference type? So for reference type, you got so many possibilities. You got person, you got account, you got scanner, you got so many other things. So what should be the reference type default value? Think about what reference type is really going to store. If I say point P, so P is a variable that is going to store an address, right? So in this case, if there's no address at the moment, we give a special value called null. So null is simply the default value for any reference type. So string, if you simply declare string S without giving some initial value, the default value will just be null. Or it can be a person, etc. Everything just null, okay? So now, let's see this. But you have to be careful. Sometimes, if you forget about to initialize explicitly to the variable about the initial value you want, there could be some danger, okay? So, and also even more, if you try to call the reference type, for example, let's see here, sometimes you might just forget. Let's say over here, something you gotta be very careful. So, oh, I didn't turn on my iPad, did I? Let's do it quickly. Okay. Okay, let's now talk about reference type. That's actually more interesting. So let's say over here, if you have, let's say points over here, point P. And then let's say you have some code over here that's irrelevant. At some point, you're trying to say P dot, let's say move up by 2 units. Let's say that's what you say in Eclipse. If you are experienced enough, what Eclipse will warn you about is you might have a null pointer exception here, right? Because over here, at this point over here, because P was not initialized to like a equals new point, you didn't say that, so no address will be stored. In this case, the default value would just be null. will just be null over here. And let's say you never change it. And then at this point, P is still null. Okay, so in this case, this may cause some null pointer exception. So this is the most common exception you might get. So every time you're trying to make a method call, you want to make sure the call targets, the context object must be not null. Then one way to ensure that it doesn't happen, null pointer exception, is make sure every time you declare a reference variable, initialize that. Eclipse can give you some useful hints, but I would say don't rely too much on the tool. Make sure you always initialize that. You mean, okay, say that again. I'm not sure I really understand you. Yeah. No, you wouldn't actually. No, you wouldn't. So the question was, if I simply just do the line like this, if I simply say point P, is Java going to implicitly call the default constructor for me? That was the question, right?
If you define one.
Huh?
If you define one with no argument.
If you define one, well, if you did it, it doesn't really matter. What you said over here, you're only doing the declaration. You're not calling the constructor. If you really have some default constructor you mentioned, you have to call that explicitly. Java wouldn't call that for you, right? Okay, still simple here. Okay, so now this comes a little bit more interesting. So far, we talk about attributes of primitive type. Let's say weights is of type double, and name is of type, well, string is reference type, but it's also simple, right? But now we want to have something a little bit more complicated. So now attribute may be reference type as well. For example, let's say in the person class, we declare another attribute called spouse. And spouse should be a reference to some other person. Okay, let me illustrate that to you, what can happen at the runtime. And then we'll see some code for this in a moment. Okay, we can do some example in just a minute. Oh, sorry, add a page. For example, let's say we have let me just use different color here. Let's say we have a person called Jim over here. Jim is a person. Let's say one of the attribute is spouse. Let's say we have another person object at runtime. Okay, let's say, for example, Lisa. I hope there's no Jim and Lisa in the class, right? If there is, I will change the name. I don't want to embarrass anybody, right? Okay, person here, Lisa here. Okay, let's say when we first create Jim and Lisa, let's say to begin with, let's say their spouse field is simply null. So they're still single, right? So it would make sense to, I'll show you how you can do that. But let's just imagine we have such a method. You can now say, so you would say Jim dot spouse, basically, is referring to the spouse field for Jim. In this case, it would just be null. Okay? Similarly, Lisa dot spouse is also null. Okay? That's at this moment. Let's say we are going to define a method in just a moment. I'm going to show you how you can do that. Now, if I say Jim dot spouse, oh, sorry, no. Let's say that Mary. Let's say we have a method called Mary. And then if I say Lisa here. Before we see how we can define this method, why don't we have a look at how the runtime structure is going to change, right? If I say Jim.Mary Lisa, how many pointers do you think I need to change? Is it just one or two? Okay, first of all, I'm pretty sure I need, well, if I say Jim.Mary Lisa, right? Of course, and first of all, I need to make sure I set the spouse of Jim to be Lisa. Would that be enough? Wouldn't be, right? That'll be weird, actually, if I don't change the other one. Now, in this case, the Jim, okay, let me make it a little bit interesting to you. So now, let's say after the blue line, what do we have? Jim.spouse is exactly equal to Lisa. They refer to the same objects. Okay? However, If I say Jim dot spouse dot spouse. By the way, for the dot, I'm going to show you a little bit later. For dot, you can just do as many times as you like, as long as they're valid. I'll show you what that really means. Now, is this, when I say this is equal to Jim, so I know the previous one is true. What about the second one? False, right? Let's see how we follow the pointer. How about that? Over here, when I say Jim, Jim is here. Jim dot spouse basically is referring to this pointer here. This is Jim dot spouse, which is Lisa. Jim dot spouse is going to follow this link here. Currently, it is not Jim. That is supposed to be the second step for the Mary method, right? So for the moment, it will just be false. Any questions until now? I just want to show you it is possible for the attribute type to be something other than integer and double or anything, right? Okay. At the runtime, you can traverse between the objects for as many links as you like. That's very common. That's so interesting about object orientation. Okay. I'll show you how you can do the Mary method in just a moment. Okay. Or now that we talk about it, why don't we just go there? Okay, I think it's just one of the methods I want to talk about. Okay, yeah, question, yeah.
So in order for what we declared was false, or in order that to be true, do we have to like put Lisa dot Mary to Jim?
That's a good question. So basically, think about, so when you call Jim dot Mary, that method itself should really do two things, right? To set Jim dot spouse to be Lisa, and Lisa dot spouse to be Jim as well. That should be done in the same method. You don't really have to call the Mary method again, which means I don't have to say Jim dot Mary Lisa and then Lisa dot Mary Jim.
Okay.
Right? You don't have to marry twice, right?
So it does that for you.
You should do that for you. But now you see exactly how that can be done. Yeah, go ahead.
So then why is it false if it does it for us?
For that one? Oh, I'm just saying if the Mary method was wrong,
Okay.
which means it only does one link. That's what I meant. Yeah. Yeah. Questions or? Yeah, okay. Okay, let's now see exactly how we can do it. And we're going to apply something that we learned last time. Oh, you will see very clearly what it should be. So now let's say we have a person class, we got name, we have spouse, and we have constructor here. You can see this is a very interesting choice. You can see when we first initialize a person, we are not required to specify their spouse. This makes sense, right? Because a person can just be single by default, right? That's kind of the design choice you make. Okay, let's see how we can define the Mary method here. Okay, I don't want to show it to you. So now, I'm going to put a question over here, and then I want you to think about how you can do it, and then I'll illustrate it here. At the page below. Okay, now let's say, let me just draw the sketch for you. So now we have the person class. Class person over here. And then we have, let's say we have spouse. Let's say we have string name. And then we have person spouse. Over here. Let's say the method I want you to try, we'll do it together, is void, and then Mary, and then it's going to be another person. That's why I'm declaring a person here. Let's just say other. And now, what should we do inside here? As I said before, there should be two steps, right? Okay. This is how we can do it. Okay. And of course, one example would be if we say Jim dot Mary Lisa. Okay, let's just try to replace something over here. You can see apparently Lisa here is other, right? We're gonna think about Lisa somehow can be one instance of the Mary method. And the context object is really Jim. Remember, how do we use, what keyword do we use to represent the context objects? This, right? So somehow in your Mary method there, you may want to make use of the other, which is Lisa, and this, which is Jim. Okay? So now, remember there are two steps over there. Do you guys want to think about it, or should we just go through the answer together? You kind of knew it? Okay. How about let me break it down into, it's very easy. First step, How do I say the current object, which is Jim, is going to set its spouse to be other? Spouse equals other. Or I can say this dot spouse is assigned to other. This one is not too bad. And the second step, I'm going to leave it to somebody else. I'm pretty sure you know. Okay. Oh, I'm sure you know too. Anybody want to try? What about second step? I want to say now Lisa's spouse should be Jim as well. But Jim is a current context, right? Right? What should I do? Nobody? Well, wow, that's a good guess. Yes, exactly. I'm sure that's what you. So now we can do other, which is Lisa dot spouse is assigned to this. Okay, so don't be afraid to use this. This is simply the representation. It denotes the current objects. So let's try to do the substitution as we did before. So now we know that Lisa is the parameter. So now we know that, let me use red. So Lisa is other over here, and also Lisa is other over here. And Jim is this. And Jim is this. So that's why I said before, it's really fundamental for you to know how to understand the method called using substitution. Again, you want to know what the context object is, what the parameter object is. In this case, if you define it this way, it's going to be Jim, the spouse, is assigned to Lisa. And then Lisa, the spouse, is assigned to Jim. It would just work well, quite well.
Would this work if this dot spouse equals this?
The question was, would it work if you say this dot spouse is assigned to this?
I say it would. If it's after the first. Yeah, after the first one.
This dot spouse is equal to this.
This dot spouse.
Yeah. Yeah, that will work. That will work. Mm-hmm.
Well, which way is it better?
I would say,
Let's say.
yeah, it doesn't really matter. It doesn't really matter, right? Yeah, it doesn't matter. Yeah, as long as it works. Okay. Okay. I want to just show you one more thing. So, should there be any precondition for marry? There should be, right? Let's think in reality. It better be both person are single, right? Or well, let's say that's the case, right? Let's talk about normal case. Yeah, exactly. You can have some, yeah. You can program that. You can say, how would you say both persons are single? You can say if this equals now, sorry, not this, sorry. I'll write it down. How do you say both are single? You can say if this dot spouse equals now. I'm just saying if this is the case, I'm going to throw some illegal argument exception, right? I'm not going to. So if the current one is single and also other dot spouse equals now, that means both persons are single. In this case, I can go ahead and marry them, right? And then otherwise, illegal argument exception, right? You'll see in the slides. I'm just sketching the idea. So I'll leave it as an exercise for you. Think about how would you do divorce? Now, it's an interesting design question. Should the divorce method take any parameter? You shouldn't, right? Because, well, presumably you want to divorce somebody who is not single. So their spouse, you don't need to say that, right? It'll be very strange. Let's say Jim's current spouse is actually Lisa, but you say Jim.divorce Mary, right? That'll be strange, right? So you don't need any parameter here. Again, it's a design choice. Think about what makes sense. Yeah.
So, for the marry method,
Yeah.
I think this cannot be now, right?
These also cannot be now. That's correct. Yeah, I didn't really put that. Yeah, that should be a precondition as well. So you want to make sure you marry to somebody, and that somebody is also single, right? That's to be precise. Very good. But this basically, the reason that I'm talking about this method here is we can use this on the right-hand side over here. So that's the main thing. Just want you to know there are many situations you will find this useful. Okay. Okay, let's go back. Okay, you will see the answer here. You can feel free to have a look. Okay, let me just go back to our Java data type, and I'll talk about some more interesting example. Okay, default value, we talked about it. Okay, that's one. Okay, so now, so what we just said was the attribute can be objects, and parameter can also be object. We have seen that already, like a marry, right? You can see you can marry to somebody else, and the parameter is exactly some class over here. Okay, we'll see others. So now this one is more interesting. This one, let's have a look at this one. This one here, I'm going to do it on the pad as well. Let's try to see what this is trying to do. So let's try to do, so there are two methods here. Under the point class over here, we have two methods. The first one we know pretty well already. It's a mutator method. Given a point, let's say p dot move up by 3. It's going to change p exactly. But now, this new method here, I'm trying to do slightly different things. Let me just try to put it up for you. Okay, and then let's see how we can understand this. Okay. 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 So now again, let's say we have two methods here in the point class. Okay. And then we know we got x and we got y. So let's say void move up by, and then we have, let's say, just make integer, make it easy, some units. What we said before is, you can simply say y plus equal u. Now, here's the new method. Let me just declare that first. So now the new method is not a mutator anymore, it's an accessor. So it's a point here, and then we'll say moved, okay, up by, and then integer and u. The parameter is really the same. The only difference is we have some return type over here, being point. Okay, what do we want to do? Let me give you one example here. So let's say this is your two-dimensional plane over here. Let's say P is currently, let's say 2 and 3. Okay? If I say P dot move up by, let's say 2. In this case, it is going to return a new point back to me, like a point object. And then, remember what I said in the beginning. If you are calling some accessor method, you better store that or print it out. Okay? So let's say we can say point P2 is assigned to this. Okay, let me show you. So over here, basically, you want to say, basically P2 is just going to be a brand new point, and then it's going to be 2 and 5. Different points. So we don't really modify P. We simply just return the new points. And that point is basically 2 units up from P. Okay, that's kind of how you use it. Okay, so now let's see how we can define that, and then we can see that again. Okay, let's see how we can do that. First of all, we know that we want to return a new points. So why don't we define that new point first? So inside the method, you can also declare new objects, right? That's something you want to get used to. So I can say points. Okay, I will just say other is simply a new point over here. So now, what should I set that position to be? Because somehow I knew that the new point is going to be 2 units up from P1, which is this, right? In this case, what I can do is I can say this dot x, comma, this dot y. That's the first step. And then what I can do is I can say other dot move up by, and then some units here. I'll put u here, and then I can return other. Okay, we'll see how this can be done. Okay. Let me just erase this. That's a little bit way too big. I'm gonna make some space so I can illustrate. So basically, that's 3 steps. Okay. So now let me just write it down again. Yeah, that's okay. I know it's a little bit confusing, but let me clear that up for you. You can see there's a D over here. Sorry about that. Yeah. Okay, that's the difference. So there are different methods. Okay, good. So one moment. So this is the method call we want to analyze. Let's see this. So let's say we have points P2 is assigned to, let's say, P dot moved up by, and then 2 units. Okay, let's say this is the line of method call we want to analyze. Let's see how we can do that. Okay, let's see. First of all, let's see which method are we calling. We're calling moved up by, which is here. Okay, first of all, let's do the simple things. We can instantiate the parameter, which is 2. So we're going to instantiate every occurrence of u just by 2. We got 2 over here. We got 2 over here. Only 2 places. Let's do that first. And then let's replace the context objects. The context object is going to be, let me use red. The context object is simply just P over here. So we're going to have, so this will just be P. And this will just be P as well. And that's it. Okay? So far so good? Okay. Now let's try to see what we are doing here. Okay? Now let me just draw some diagram to show you. So now, let's say over here, just for this line here, what we're doing is we have other is a variable. It points to some objects of type point. And every point has x and y, right? So now, how do we initialize this particular other? Well, it's going to be, remember how we trace the constructor. Let's save that step for now. So other.x is going to be p.x, right? p.x is 2, right? So that's why we put 2 over here. What about p.y? 3. I just didn't draw the diagram for p, but it should be somewhere in the memory, right? This is 3. So basically, we are creating other initially just identical to p, but they're different objects. We just copy over the x and y values from p into into other. Okay. Now, when we call this method here, make this method call. The context object has changed, right? Used to be just p, but it's not other. So other has become the context object over here, right? But which method are we calling? It's a different method here. So now, let me move up by over here, and it is this method that we are calling. Right? Good. So now, let's see how we can do that method there. Now, we can see that u has been replaced by 2 previously. So now this u here also has to be replaced by 2. Right? Just different levels. And then we know that when you say y plus equal u, that's simply this, dot y. But now, what's this right now? Other, right? Good. Thank you. So now, other should be this. So now, basically, we're doing other.y plus equal 2. That means we are changing this to be 5. And notice that we're only changing other. We are not changing p. P is untouched. Okay? Yeah, just before you ask your question. So now, that's the second step. Now, for the third step, we are simply returning the address of other. Okay? Return the address of other. And basically, let me just do a final illustration here. So basically, this whole thing over here is going to return the address of other. And we can store the address of other into P2. As we learned before, that means P2 is going to point to this particular object, right? That's what we have done. So basically, we are returning an object that's completely independent from the original P, the context object. Yeah, questions?
Where did we initialize P?
Oh, I didn't really do that, but of course you can imagine that we actually did that, right? Yeah. Okay, you know what I mean, right? Yeah, that's kind of from the previous lecture. Right? So you see, today we're doing something that's a little bit more sophisticated. So now we are trying to call the constructor inside some other method. But the way we trace it is pretty much the same. It's a little bit more sophisticated. But I think it's really important to know. You see lots of things like this in object orientation. Any questions before I move on? Yeah.
What's the use of this when we get simple constructor? What to call it?
Well, what's the use of this? So in some way, you see, sometimes when you are trying to call a method on some objects, you don't necessarily want to modify that particular context object. You may just want to create another thing, right? In this case, you can, well, for example, let's say this. Initially, that's a good question. Why do we need this, right? Why? Initially, we only get the green part, just 2 and 3. Now, let's say we want to duplicate some points, but we don't have to do from scratch. We don't have to say point P2 is assigned to new and then some points and then do accordingly. What we can do is I give you a reference point, which is P. I say P dot moved up by 2, which will give me just another point to say it's going to be a point that's above P for 2 units. Yeah, just returning another object. Yeah.
Well, I think you meant like why not just call the point other with the constructor that's put.
Yes, you can do that as well. But this one is a little bit better because you don't really have to call the constructor in 2 lines. It's just one single line would do, right?
We don't have to do it from scratch.
You don't have to do it from scratch, exactly. In some ways, it's like a helper method for you, right? Mm-hmm. Any questions? Good. Okay, let's go on. So now let's see something that's even more interesting. So now we have seen that for your attributes, for your method parameter, and also for your method return type, they can all be object type. And guess what? It can be even more complicated. Your attribute can even be an array list. And back to your question, why do we need this? You will see that, right? It's like a collection, okay? Let's say we have a class called point collector, okay? Well, it's quite obvious what it is going to do, right? It's going to collect points. So now, array list, I presume all of you have seen that more or less, right? Back in 1022, okay? So I can start talking about it. Of course, the type of the points over here can be array, just simple array, like what you did for up to now. Or it can be linked list, or it can be any other data structure that you might learn later. But for now, let's stick to array list. So now, I wouldn't talk too much about generic parameter yet, because we'll talk about it a little bit later. But you can simply say array list of points, which is to say every element in the array list is of type points. Okay, let me just show something to you that's really also really important to notice. What does it really mean when I say array list point? Let's do some illustration here. So when you say array list and then points, and then points, this is a declaration. So what does that mean? This means at the runtime, points, which is a variable, stores the address of an array list objects. First of all, and then every element of the array list. So what do they store? Can you take a guess? Do they store integer or do they store string? They store object. To be more precise, they store address of some point object, right? Every element of the array list stores the address. I'll show you some simple code in the pad in just a moment. Store the address of some point objects. Okay, just some concept over here, and then I will illustrate to you just with some simple code. Okay, let's see how we can do that. Okay. First of all, let me repeat that. So I can say array list, and then I say point over here. And then I can say, you know what, before I say that, sorry about that, let me say point first. Point P1 is new point 2 and 3. Let me have another one. Point P2 is new point 5 and 7, just for now. Okay. So what we have done so far, we have P1. Okay, let me draw it here. P1 over here is pointing to an object of type points. P2 is pointing to another object of type points. So we have x and y, and we have x and y as well. So now what about the value? So one would be 2 and 3. The other one would be 5 and 7. Okay, so far so good. Nothing complicated. So now let's declare that array list and see what's going to happen. If we say array list, and then we have points, and then let's simply call it points over here, is new array list. In Java, you can simply don't have to repeat the type. You can just say that. Okay, that's what you can do. So this means we're creating an empty array points, empty one. Okay. For convenience, this is how I'm going to visualize an array list. I'm going to visualize it as just like an array. Okay. So now, up to now, we have points over here. It's basically pointing to some empty array, just empty for now. And then I'm going to say points dot, one of the methods you can call is add. Remember, add actually takes some type of the elements. In this case, we're storing points, so you can say P1. Okay, so that means we are now having one single element that we can store. That's element number 1 of index 0. Array list index starts from 0. So now what does that mean here? When we say add P1, that means the first element of this array list over here is going to store the address of P1, right? To store the same value. That means it's going to point to over here. Okay. Similarly, after this, I can say points dot add, and then I can say P2. What this will do is going to grow the list. You don't have to worry about how they grow the list. It's actually hidden from you. It's an API. 1, and then it's going to point to over here. So you can see now we have 2 occasions of alias over here. So now, you can feel free to try this in JUnits, but I'm going to write it down here. You can try. So now what we can say is, if you now try to write this assertion here, if you say points, which is array list dot get 0, it's going to, so points is this, dot 0 is going to point to this object here, right? If you say equals P1, you're asking if points at position 0 is referring to the same objects as P1. Of course it is, so it's going to be true. Similarly, if you say points dot get, and then I pass 1 over here, and of course that will also be P2, right? That's true as well. Any questions until now just about this? This is just to show you how you can visualize array list of some object type. Yes?
Instead of add, can you use like set?
Oh, set. Good question. What about we say set? Now, it's a very good question. Let me use a different color here. Pink. Now, let's say after this, if I say points dot set, I believe the set will take 2 parameters, index and some new points. What about I say 0 and then P2? Okay, let's try to see. It's a very good question. I haven't thought about it. Okay, so now, what is the pink one saying? I'm trying to set the elements at index 0. I wanted to store the address whose value is the same as P2. So that means for index 0 here, it's not going to point to this anymore. It's going to point to this. So after this, what's going to happen? After this, if I say points dot get 0 equals points dot get 1, that will also be true because now they are referring to the same objects. Any questions? Yeah. You can feel free to try this in Java, but we'll do something else in Java. Yeah.
This method doesn't work on arrays, right?
Array list. You mean for array? You mean like primitive arrays? No. You know what? That's the thing. For the primitive array covered in your lab test 1, somehow you don't have any method that you can call. The only thing you have is like an array.length. Yeah. However, for array list, you can have more methods. Right? Mm-hmm. Of course, you don't have to worry about how the set method or how the get method or how the add method are implemented. It's not your concern. It has been done for you. Yeah.
So the primitive arrays we use in lab test, are they objects or
They're also objects. They're also objects. Just for your information. Okay. Let me do that very quickly. Okay, just for completeness, and then we'll go back. Okay, so for now, let's say this. So now, let's say if I say points, the same idea, right? Usually, for the square bracket, you will simply say int, string, or double. Now, I simply put a class name. This has the same idea as array list, which means every cell in the array is going to store the address of some point objects. The same. Let me just show you some code, and then so you can say points is new, and then points. For now, let me say size 2. Up to now, we are basically creating points over here. It is store the address of an array over here of size 2, 0 and 1. At the moment, what would be the value for the 2 slot? Null, right? Because we haven't set anything yet. So for now, it's simply just null. Okay? After this, what we can do is we can say points is assigned to something. Let me show you another notation. I'm not sure if you have seen this in 1022. It's called anonymous objects. I would say new point. Oh, sorry. Should be 0 here. Okay, point 0. And then we have new points 3 and 4. This is valid Java code. Okay? So basically what this means is usually when you say some point and then P is assigned to new and then point and then 3 and 4. Remember what we said before. If we only talk about the right-hand side over here, what does it do? It simply creates an object in the memory and then somehow get the address. And then it's only the remaining 2 steps that is going to store this address into P. But now we just ignore that step, which means we get the address directly. Okay? So now we simply say, create this object here, and then store the address into the first slots over here. Okay? Just for your information here. So now what this will do is, so now this is going to point to a new object there, and then of type points. We have x and y, and 3 and 4. Okay. But I would say, since I mentioned only array list in the slides, I would say it's just to be simpler, just focus on array list. Okay. Okay. So now, what I would like to do, for this particular topic, I would like to pause here a little bit. I would like to resume this topic on Tuesday. I want to talk about equals method first, and then I'll come back to here, okay? Because somehow we're running a little bit behind schedule. So I want to cover the equals method at least today, and then we'll continue from this on Tuesday. But any question about array list, you can still review this slide about array list, and then we'll come back here, okay? Any questions before I move on to equals method? Okay? Let's talk about the equals method. Hopefully I can finish that bit by the end of the class. Equality, yes. Okay, let's talk about equality. Basically, there are two kinds of equality in Java or in any object-oriented language. Either reference equality equals, which means you compare the addresses. Or if you want to compare the contents of the objects, then you have to do a little bit trick over there. Okay. First of all, let's say we have known this already, right? If you got P1 and P2, they're two separate objects. If you simply say P1 equals P2, in that case, no, it's false, because they have been created from two separate keywords, like a new keywords over here. So this is a new object over here. This is a new object over here. However, sometimes it might be useful to say, we don't really just want to compare if they are the same objects in the memory. We want to see if their contents are the same, something like this. So let's say if I have something over here, what I want to have is something like this. So let's say we got P1 and P2. So I have point P1 is new, point 2 and 3. And also we have point P2, new, point 2 and 3. Somehow we know that this Boolean condition here, P1 equals P2, is false. We know that because it's comparing addresses. Okay? However, what we really want to compare may not be their addresses. We want to compare their x and y coordinates. We want to see if they're really in the same location. So on the other hand, number 1 is false. What about number 2? If I say P1.x equals P2.x and P1.y equals P2.y, would this be true or false in this case? Should be true, right? So that's really what we really want to do. However, you really don't want to just write this kind of Boolean expression every time when you want to compare 2 points. It would be much more convenient if somehow you can reuse this block of code by defining a helper method, right? This kind of helper method is called equals in Java, okay? So what we really want to do is as follows. We want to somehow define a helper method called equals for this. Okay? So rather than saying P1.x equals P2.x all the time, we can simply say P1 dot equals and P2. That's what we want to achieve. Okay? But to define this method here, you have to know how to do it, right? So there are certain requirements for this particular course, so I need to go over for the equals method. Okay? Any questions so far? Okay? By the way, you should really somehow recognize this block of code over here. You will see that somehow this block of code will appear in our final equals method definition. So this is really the core part, right? But somehow there will be some other issues to take care of since we talk about some method call. Okay. Okay, now let's see equality here. I think there's some slides. Okay, let's just see if you got some primitive variable. If you got D1 and D2, right? If you're D1 and D2, if you simply say D1 equals, okay, let me see what I want to say here. So here you can see we got D1 and D2, they're primitive. And P1 over here, it's objects. And P2 is also an objects, P1 and P2. So now here, it really depends on what you're comparing. If you say D1 equals D2, because both sides are primitive, so you're comparing their values, like 7.5 equals 7.5, so they are true. On the other hand, if you say P1 equals P2, you're not really comparing the objects per se, you're comparing the references of the objects, the addresses. Okay, it is like a repetition. Okay, so now there's something a little bit tricky here. You heard about a class called objects in Java. So we're going to talk about inheritance a little bit later in the course. But now let me just do a little bit preview. Basically, inheritance is about code reusing. So there is a class called objects in Java, where, so this is how you can represent it in diagram. So let's say we talk about points and also objects. Okay? So there is a class called objects in Java. And basically every class is so-called a subclass or a child class. So this is called the parent class. And so I just draw an arrow here, and I have the class, for example, called points. Okay, just that. Okay, objects and points. And similarly, if you define any other class, they will always be the subclass of objects. Okay, so now everything that you declare in objects will be made available to the class. Okay, so I want to mention just one method for today. So one method in object class is called equals. It has the signature like this: Boolean equals, and then of type objects. I'll say O here. That's a signature. So this is the method we're going to focus on today. So this is a method that is defined in the object class. And because of inheritance, this method here will be inherited into every class, including the points, which means by default, there is already a equals method there, which I'm going to illustrate to you. Okay? It's already there. Boolean equals objects O is inherited. And the definition for the equals method in the object class is very simple. It's only one line. The definition looks like this. You simply return this equals O. That's a one-line definition for the equals method. So now, what does this line mean? That means whenever you're trying to compare some objects with another object, you only compare the references to see if they're the same objects. That's by default. However, this is not what we want for the point class. So we want to somehow redefine the equals method. Okay? So it's actually very often you have to do, because the equals method, which you inherit from the object class, is not exactly what you want. So you have to redefine that. Okay? Let me illustrate it to you in the Eclipse. Okay? So now let's do that now. I'm going to continue from the point class that we did from last time. We're going to build on top. Okay? Let's see what's going to happen there. Okay, so we got two-dimensional points. So now let's say this. So now at the moment, I want you to pay attention to this. So for the point class over here, you can see there is no definition for equals method. Don't you agree? We haven't done anything like that yet. However, as I said before, every class is going to inherit the equals method from objects. So even though we didn't declare the equals here, it's already there implicitly. Okay, so we can already use it. Okay, so now let me show it to you. So now let's go to test point over here. Add test. Public void test. Let's say default equals. So now let's see how we can do it. Okay, let's say point P1 is new point 2 and 3. Point P2 is new point 2 and 3. Okay, and now let's do something here. Assert true. P1 dot equals P2. First of all, you can notice that this line compiles, which means the equals method is really there, even though we didn't declare that in the point class. It's inherited. However, is this test going to pass or fail? Well, it's going to fail, right? So let's see why. We're going to see, first of all, let's make sure it fails. Okay, very good, it fails. Now, let's see why it fails, right? This is really important. I want you to, again, I'm going to show you in breakpoint and debugger, okay? I'm going to put a breakpoint over here, And then I'm going to run the debugger here. Now, I want to see which version of equals it is calling. Okay. So now, if I step into, I'm going to step into it. If I step into it, you can see that it is now we are now in the object class. It is calling this equals method here exactly what I shown on the pad, right? It's now saying return this equals objects. What is this? P1. What is obj? P2. So I'm basically checking P1 equals P2. Of course, it's false by default. Okay, everybody follow? Okay, very good. So now, to read, how do I make a green bar? Assert false, right? So what I really want is to have a method that is not going to compare references. It is going to compare some object, right? So-called object equality. So I'm going to show you now. Let me make sure everything passed because I changed it to assert false. Okay, good. Now, for clarity, I'm going to create a new class. Okay, let me make a note for you here. At the end of points, I'm going to say, there is no redefinition of equals here. So the inherited version from objects class is used. Okay? And this default version compares references only. Okay, that's what we have seen. Okay? Now I'm going to do the following. I'm going to have a new class called point2. In that point2, I'm going to show you how you can define the equality properly. There are several steps you got to follow. Okay? Point2. Okay, let's declare the two attributes quickly, double x, double y, and also we got point2 here, double x, double y, and then we can have this dot x is assigned to x, this dot y is assigned to y. Okay, so now we want to now redefine the equals method. Redefine, and in Java term it's called override. Override the inherited equals method from objects. How do we do that? In Eclipse, it's very convenient. You can simply type equal as part of it. It shows you the equals object version, right? So if you do that, it even show you that it's an override version. Okay, which means we'll talk about the super keyword a little bit later. Okay, so let's see how we can do that. So now, whatever we enter over here is going to be the new version for point2. You can see now the difference between point and point2. In point, we simply use the default version of equals. In point2, we use the redefined version. Okay? So there will be several steps we have to follow. Let me go over some slides to see how we can implement this, and then I will go to the code. Okay? Okay, let's see. So this basically you can go over this slide. I said that already. So that's the code, but I want to talk about the requirement first. So now let's say, whenever we say p1.equals, basically, let me just say again, what's the context we're dealing with? And then we can make a definition. So basically what we're saying, p1 dot equals some objects. So this is something we want to define in general, like that. Okay, the equals method is what we're going to define, and P1 is guaranteed to be a point. But objects can be any objects. When I say any objects, it can be a person, it can be a string, or it can be a point, it can be anything. If it happens to be points, that's good, we can keep comparing. If it doesn't happen to be a point, how can you compare a point with a string? Of course, it should just be false, they are not equal. Okay, so there are different possibilities over here we gotta consider. Okay, so now let's go over this possibility here. Okay, first of all, let me ask you just to get your intuition. And then we can define that gradually, okay? Let's do that together. Again, let's assume we have point P1 new point 2 and 3. Let's think about the easy case. Now, let's think about what you expect from this equals method. If I simply say P1 dot equals P1, should that be true or false? Because you're comparing the object, if the object you're passing there just happens to be this, of course they should be equal, right? So this should be just true. Should be true. Okay, let's code it up right away. How do we do this in Java? Okay, if objects and this refer to the same objects, true. We can say if this, which is the context object, in this case that'll be P1, equals obj, which is also P1. In that case, well, no brainer, return true. Yeah.
How does it know this is pointing to P1?
Good question. Remember, we talked about context object, right? So now if you just go back to the pad over here, you can see we got P1 that equals P2. Oh, sorry, P1 that equals P1. In this case, P1 is context objects and at the same time also obj. They happen to be the same. Okay? Yeah. Even, okay, I don't want to complicate the matter. Okay, that's good. Okay. Okay, so that's our first case. So now what about second case? What about if I say P1 dot equals null? False, right? Because P1 certainly points to something there. By the way, if P1 didn't point to anything, this would be a null pointer exception, right? So that's another issue. So now P1 is context object that equals nothing. Of course, you cannot compare them.
So for the first relation, because we know P1 is a parameter, so but for the equals method, we save our object reference as parameter.
Yes, and you're talking about callback reference, which we'll talk about.
Compare the point object reference with another.
Of course, you just compare if they're equal or not, right? Similarly, so let me just strengthen point number one. Let's say I got another point. Let's say P2. Let's say, see here, I said P2 is assigned to P1, right? We talked about this already before. So now P2 and P1 refer to the same objects. Now, if I say P1 dot equals P2, will I also get true? Right, the same idea. We're just comparing if they're the same. Right? Okay, similarly, so now P1 dot equals null should be false. Let's code it up. So now I can say if other equals null, in that case, just return false. That's the second case. OBJ, sorry. Yeah. Okay, third case. Third case over here. So now let's say I have this. Let's say I have string P3. Okay, it's deliberate to be confusing. Okay, P3, it's a string. Oh, sorry about that. It's like that. So now, if I say P1 dot equals P3 over here, true or false? False, right? Even though P3 is kind of looks like a point, but you know, I tell you what, this is even easier because they are of different types. One, we're comparing apple with banana, right? You cannot compare. So this is no, and this is also no, false. So now the question is, how do we check if they are of the same type? So there is some utility for you to do in Java. I'll just show you how you can do it. Okay? Somehow you want to know the type for P1 is point. That's how we declare. And the type for P3 is string. That's how we declare. And they are not the same. Of course, they cannot be equal. No way. Okay. Okay, this one here, I'm going to do it. So I can say if, okay, I can say whatever, okay, this, which is P1, dot get class. This will give me something which represents the class of P1, which is point. Okay? You don't have to worry too much detail about this line here. I would say, don't really memorize it. If I really want to give you a question about this in lab test 2, you can have a cheat sheet. You don't have to memorize. I just want to explain what that really does. Let me finish this line and then you can ask. If they are not equal, thank you. In that case, so one is point, the other one is string. They are not equal, so return false. Okay, so far we talked about 3 cases.
Instead of this, can you rather use people?
You mean,
I mean, instead of get class, can you compare type with
You-
this triple equals object?
you mean this dot equals object,
Equals sign.
3 equal sign. You mean like that? I'm not sure if this is such an operator in Java. I don't think so. JavaScript? Oh, actually, you know what? Forget about that. No, yeah. No, you cannot do that. Oh, really? They allow that? No, you cannot.
I've never heard of that.
Oh, guys, you know, what did they do to you in this first year? Yeah, forget about triple equal. There's no such thing in Java. I don't think. Yeah, not equal. Okay? Yeah, I'm so glad you asked me. Yeah. I'm going to put later in 2030 to say, forget about JavaScript. Okay, fourth case, and then I'll do that very quickly. I'll leave the detailed explanation a little bit later, but let me see how much I can do. Okay, let's do with whatever time we have. Okay, fourth case. Let's say over here, let me create P3 as well. Let's say point P3 is new point. Let's say it's 2 and 3. You can see now P3 and P1, they are not the same references, right? So now, however, if I say P1 dot equals P3, at the moment it will be false. But what do we expect it to be? We expect it to be true because we really want to compare contents, right? The x and y coordinates. That's something we expect it to be true. Expected. I'll just say true. Well, at the moment, we haven't defined that yet. I'm just saying, ideally, we want it to be true, right? Right? So, you know, in some way, I don't really show you the code first. I show you what the expectation is, and I go back to how we should code it. Okay? So now, let's see. I'll do that quickly, and then. So now, naively. So if I can reaching this point, I know that this and other are of the same type. Because there's no return before, right? No return has happened so far. So now, naively, you might want to say this dot x equals obj dot x. And this dot y equals obj dot y. This is what you may want to do. However, not going to compile. It's going to say something like this. You will say x is somehow not a field of objects. Okay? I will tell you what the solution is right now. I'll write it down to be complete. I will explain that on Tuesday. Let me write it down. What you got to do is something called cast. I'll explain what a cast is next time. You're going to say point other, that's where I want other, is do a cast, and over here, obj. And then, rather than using obj, I'm going to use other here. Yep, everything compiles. Okay, so we have talked about the 4 cases for equals. So next Tuesday, I'm going to start with the explanation of these, and then we'll move on to other methods. All right, see you later.